Ever wondered how the humble wire plays a vital role in the world of electronics? Well, today we're going on an electrifying journey to uncover its secrets. Our first stop is a simple yet effective experiment to find the resistance of a given wire using a meter bridge, thereby determining the specific resistance of its material. Start by connecting the wire to a meter bridge. Then, adjust the jockey until the galvanometer reads 0. Note down the lengths on both sides of the bridge wire and use the formula for balance condition to calculate the resistance. Next up is a fascinating activity to determine resistance per centimeter of the wire by plotting a graph of potential difference versus current. Begin by connecting the wire into a circuit with a power supply, ammeter and voltmeter. Measure the potential difference across the wire and the current through it for different values. Plot these values on a graph and the slope will give you the resistance per centimeter. Now, let's verify the laws of combination of resistances using a meter bridge. Connect two resistors in series or parallel on the bridge and record the balance point. Repeat with the resistors swapped. The results will demonstrate the laws of combination. Our journey continues with the comparison of the EMFs of two primary cells using a potentiometer. Connect the cells to the potentiometer circuit and adjust the jockey for 0 deflection. The balance length is proportional to the EMF of the cell. Next, we'll determine the internal resistance of a primary cell using a potentiometer. Connect the cell in parallel with the resistance box and adjust for 0 deflection. Repeat for different resistances. The internal resistance is given by the difference in EMF divided by the change in current. Now, we'll determine the resistance of a galvanometer by the half deflection method and find its figure of merit. Connect a resistance in parallel to the galvanometer and adjust until the deflection is half of the previous value. The resistance of the galvanometer is equal to the added resistance. Our next activity is to convert the given galvanometer into an ammeter and voltmeter of desired range and verify the same. Connect the necessary shunt resistance for the ammeter and series resistance for the voltmeter. The readings should match the expected values. Finally, we'll find the frequency of the AC mains with a sonometer. Adjust the length of the sonometer wire until you observe resonance. The frequency of the mains is equal to the resonant frequency of the sonometer. In summary, today we've explored the world of resistance, from how to measure it in a wire, to how it behaves in different circuits, and even how to convert a galvanometer into an ammeter and voltmeter. We've seen how these fundamental principles underpin the operation of all electronic devices. Now, with this newfound knowledge, the world of electronics is yours to explore. So go ahead, experiment and discover the wonders of resistance.